Alright, I'm just going to make another video to respond. And by the way, thank you everyone who replied to my questions and gave me advice. That's awesome. It's a big help. So I'm just going to get down to it. Tom Watson indicated that I should rotate the channel for the stop pin over about 45 degrees. And I can't remember who it is now, but someone told me I should also move in the lock bar closer to the pivot once I had rotated the channel for the stop pin. So I did both of those things, but now I'm running into the issue of the paths of the channel interfering with the detent. So I moved the detent down to where it doesn't collide with this channel's path when the knife is closing, and I don't think that'll be a problem. I've seen other knife makers move the detent down instead of having it up there in the corner, which is the kind of the customary spot for it. So that shouldn't be a problem, but if anybody thinks it will be great to know that before I actually try to make the knife. And then Gerard's Knives was saying that this little area, I think, I couldn't quite understand what he was saying, but I think he was indicating that this area right here, which is basically just extra metal that I'm leaving to account for the fact that I'm going to be grinding the angled lock face there. Of course, I haven't moved this whole part of the tang over prior to moving the lock bar over. But I think what he was saying is to shorten this right here to about an 1/8 inch, because, or just shorten it more because you only want an 1/8 inch contacting the lock bar. I'm not sure if that's what he meant. So if anybody has any insight on that, that'd be great. And then another question I have is, what's the importance of counterboring the blade, the actual blade, to fit the ball bearings? Because I've seen other people and other designs where the blade isn't counterbored at all, and they only counterbore the frame pieces to fit the bearings. Because that's my original plan, was to counterbore the frame just deep enough to where I'd have 0.02 of the bearings sticking out and contacting the blade. Because I figured, you know, if a lot of washers are about that thickness, it will kind of replicate the thickness of the washers. So then I can surface grind the blade down to the thickness that'll basically, like if you start with a 3/16 thickness, you would just eliminate 0.04 to account for the ball bearings, and then you can use 3/16 standoffs. That's my plan so far. So as usual, thanks for all the advice and any continued advice.